Hi students, sum number 16. A conducting sphere of radius 10 centimeter has an unknown charge. So let us take it as Q. The unknown charge which is kept on the outer surface of the sphere is Q coulomb. If the electric field 20 centimeter from the center of the sphere. So from the center O of the sphere, a point P which is located at 20 centimeter or 0.2 meter. So if the electric field 20 centimeter from the center of the sphere is 1.5 into 10 power 3 Newton per coulomb. So at this point P, the electric field E due to this charge Q located on the outer surface of the sphere. Okay. So this is E and its magnitude is 1.5 into 10 power 3 Newton per coulomb and points radially inward. So the electric lines of force starting from the point P is directed radially inward. That means the nature of the charge is given. It has to be understood that a negative charge is located on the outer surface of the sphere. So only for the negative charge, the electric flux will be pointed inward, is it not? So this is the direction of the electric field radially inward. So what is the net charge on the sphere? So the net charge on the sphere is taken as Q coulomb. We have to find out what is the value of Q. And here the electric field E, magnitude of the electric field is 1.5 into 10 power 3 Newton per coulomb. It's the magnitude. But since it is radially inward, this is its direction is negative. Okay. Now this is the application of Gauss law. One of the applications of the Gauss law. So at any point P which is at a distance of D from the center of the sphere, the electric field E is, the magnitude of the electric field is 1 by 4 pi epsilon naught into Q divided by D square. So this is an application of Gauss law. At any outward point P which is at a distance of D from the center of the sphere, the electric field, there will be an electric field and the magnitude of the electric field is given by 1 by 4 pi epsilon naught into Q by D square. So we have studied in the theory class, the electric field behaves in such a way as if the charges are concentrated at the center of the sphere itself. Is it not? Though the charges are concentrated on the outer surface of the sphere, the electric field will be as if the charges are concentrated at the center of the sphere, which is at a distance D from the point P. Understand? So this value is given as 1.5 into 10 power 3, but since it is radially inward, its direction should be what? It is inward. So its polarity is negative. So this is now E is equal to minus 1.5 into 10 power 3 Newton per coulomb. We have to find the Q. So from this expression, I can write E is equal to 1 by 4 pi epsilon naught is taken as 9 into 10 power 9 into Q divided by D square is 20 centimeter into 20 centimeter the whole square, 0.2 the whole square. Understand? So left hand side E I am going to substitute minus 1.5 into 10 power 3. So this is equal to 9 into 10 power 9 into Q divided by 0.2 into 0.2 is 0.04. Therefore Q, the quantity of charge, must be equal to minus 1.5 into 10 power 3 multiplied by 0.04. So 0.04 whole divided by 9 into 10 power 9. Okay. Now in the numerator 10 power 3 is what? 1000. So when I multiply this 1.5 by 10, it becomes 15. 0.04 by the remaining 100, it becomes 4. So that this 10 power 3 can be eliminated. So I can write now Q is equal to minus of 15 into, so 15 into 4 divided by 9 into 10 power 9. So this is a 9 into 10 power 9. So this is equal to minus 15 fours are 60. So 60 divided by 9 into this 10 power 9 turns up as 10 power minus 9 coulomb. So this both the numerator and the denominator I am going to divide by 3. So this is minus 23s are 60, 3 3s are 9 into 10 power minus 9 coulomb. So 20 divided by 3 is minus of 6 3s are 18. So 6.666 will be recurring into 10 power minus 9 coulomb. Or I can round it off as Q is equal to minus of 6.67 into 10 power minus 9 coulomb. Therefore, Q is equal to minus 6.67 nano coulomb. So what is asked in the question is, what is the net charge on the outer surface of the sphere? It is found that it is a negative charge of 6.67 nano coulomb. I hope you must have understood well. Fine.